Hello and welcome to Data Center Insights. I'm your host, Emma, and today we're returning to one of our most popular topics, the UPS systems. If you've been listening to the show, you might remember our earlier episode where we explored different UPS configurations and how each setup impacts resilience, uptime, and design choices. Today, we're picking up where we left off. Because while resilience is the foundation, efficiency is what makes it sustainable, both financially and environmentally. In this episode, we're looking at how modern UPS systems are evolving to meet today's high-density AI-fueled demands, and why even small improvements in UPS efficiency can have a massive ripple effect across your data center's operations and budget. So grab a coffee, or if you're like me, a second one, and let's talk about how smarter UPS technology is helping data centers work leaner, greener, and more reliably than ever. Let's start with the basics. A UPS, uninterruptible power supply, is a bit like your favorite insurance policy. You don't think about it every day, but when something goes wrong, you're really glad it's there. But here's the thing, UPS systems are always on. They don't just kick in during outages, they're running 24/7 to condition and protect power, which means their efficiency rating matters every minute of every day. Think about it. If your UPS is only 92% efficient, that means 8% of the energy is being lost, mostly as heat. In a 1 megawatt data center, that adds up. Now multiply that by hundreds of sites around the world, and suddenly, UPS efficiency becomes a global impact story. This is where innovation comes in. One of the most exciting technologies changing the UPS landscape is Silicon Carbide. Compared to traditional silicon, Silicon Carbide enables faster switching, better thermal performance, and higher power density. Allow me to paint you a picture. Imagine a leading hyperscaler upgrading their legacy UPS fleet to Silicon Carbide-based systems across several European facilities. Each 1% improvement in efficiency would annually save them tens of thousands of euros per site just on electricity and cooling. That's millions in savings when scaled, and more importantly, it would cut their carbon emissions dramatically. Silicon Carbide lets UPS systems run cooler and smarter, especially under the kinds of heavy, bursty loads we're seeing from AI and high-performance computing. It's tailor-made for today's data center challenges. Okay, now let's talk numbers for a moment. When we talk about UPS efficiency, power factor and harmonic distortion used to be the hot topics, and they're still important, especially for legacy systems. A near-unity power factor means energy isn't being wasted, and low harmonic distortion protects your downstream equipment from interference and wear. But today's demands go beyond that. In large-scale colocation facilities or AI-powered data centers, every watt counts. Heat, downtime, and energy losses aren't just technical issues, they're business risks. Now imagine you're running a colocation facility with hundreds of tenants. If your UPS has poor power factor and high harmonic distortion, it's not just your energy bills that go up. You're also creating heat, reducing equipment lifespan, and causing client dissatisfaction if uptime is impacted. Here's another eye-opening number. According to the Uptime Institute's latest report, over half of organizations experienced outages that cost them more than $100,000, with some hitting as high as $1 million. That's why modern systems, like Legrand's latest UPS solutions, include power factor correction and advanced harmonic filtering. This isn't just technical jargon. It's what allows the system to deliver clean, efficient power to critical loads without unnecessary waste or risk. Cooling is another big win that often gets overlooked. I recently spoke with a data center manager from an enterprise in Frankfurt. They really want to replace their legacy UPS with a high-efficiency Silicon Carbide model, because the new UPS systems would produce less waste heat. Less heat means less cooling, and less cooling means, of course, lower operational costs. Here's a simple stat to keep in mind. In a 1 megawatt data center, a 1.5% increase in UPS efficiency can equate to several $1,000s or euros saved annually, depending on your local energy rates. It also means less strain on cooling infrastructure and longer equipment life. Multiply that by 10, 20, or 50 sites, and the cost savings become game-changing. Of course, efficiency doesn't just help your wallet, it's also a major lever for sustainability. Data centers are some of the largest consumers of electricity in the digital economy. The greener they can become, the more they contribute to larger corporate ESG goals, and let's be honest, public reputation. While today, data centers account for around 1.5% to 2% of global power consumption, this figure is expected to rise to between 3.5% and 4% by 2030. High-efficiency UPS systems reduce Scope 1, 2, and 3 emissions. Less energy use, less heat, less cooling. It truly is a virtuous cycle. Some of the hyperscale players are already reporting efficiency gains in their sustainability reporting thanks to smarter UPS infrastructure. And that's becoming a key differentiator when bidding for government contracts or working with ESG-focused clients. But let's not stop at today's tech. Let's take a look ahead. The future of UPS efficiency will be powered by AI and machine learning, technologies that can analyze load patterns, predict failures, and adjust energy delivery in real time. That means even better efficiency, less manual intervention, and fewer surprise failures. We're also watching battery innovation closely. VRLA lead-acid batteries have been the go-to for years, but they struggle with heat, aging, and energy density. Lithium-ion stepped in with better performance and longer life, and now it's everywhere in modern UPS setups. We're also seeing growth in zinc-based options for grid storage and the rise of sodium metal chloride batteries, offering long life, safety, and wide temperature tolerance, ideal for industrial and critical environments. The future of UPS power isn't one size fits all. It's about choosing the right battery tech for the job. And last, let's talk about the smart grid. UPS systems are no longer isolated. They're becoming interactive. With the right setup, your UPS can support grid stability, reduce peak demand, or even provide backup services to the utility, all while saving money and contributing to a smarter, greener energy ecosystem. So what's the takeaway today? If you're operating a data center or planning one, don't overlook UPS efficiency. It's not just a back-end metric, it's a strategic advantage. From cost savings and carbon reduction to uptime and infrastructure longevity, the benefits are real and growing. Legrand's new UPS solution, Kior Flex, is designed with this in mind. Silicon Carbide architecture, smart diagnostics, and sustainability built in. It's not just about power backup, it's about powering smarter. That wraps up our deep dive into UPS efficiency. If you missed our earlier episode on UPS configurations, I highly recommend checking it out. It's the perfect companion to this one. And as always, if you're curious about what the next generation of UPS solutions can do for your operations, visit legrand.com/datacenter or reach out to the team at Legrand for a demo or consultation. Thanks for spending your time with me today. I'm Emma, and until next time, stay efficient, stay resilient, and keep your data centers running smoothly.